So now we're going to do some nomenclature for aromatic compounds. And nomenclature here is different. It's definitely the one functional group that doesn't really follow the rest of the rules as well. And on top of that, aromatics have a lot of common names. So once you learn the common names, aromatic nomenclature is actually one of the easier functional groups, just because when you think about the structure of benzene, each carbon already has 3 bonds. So you can only have one substituent at each position. And so that just, in general, makes things a little bit easier. So we're going to start with monosubstituted aromatics, which at least at first are going to seem like one of the easier ones. Because for monosubstituted, if you have some group on benzene, you just call it whatever that substituent is, followed by benzene. So for example, if we put a bromine on there, then that would be bromobenzene. So far that's not too bad. And the same thing is true if we put a carbon group. So here we have a 2-carbon substituent. So that would be ethylbenzene. So again, just literally any group that you have on there, you just name the substituent and then benzene. Unfortunately though, there's a lot of common names. And there's no way to learn aromatic nomenclature without learning at least some of the most important ones. So this compound looks like it should just be called methylbenzene. But methylbenzene, almost always known as toluene. If we put a hydroxyl group, an alcohol on there, again, our initial answer might be to say hydroxybenzene, but this is known as phenol. With an NH2 on there, an amine group, we have aniline. With an aldehyde is known as benzaldehyde. If we put an alkene on there, we have styrene. And finally, if we put a carboxylic acid on there, that gives us benzoic acid. And so what we find is we need these common names as we get into more complicated molecules. Alright, so those are our monosubstituted benzene rings. What happens when we go to 2 substituents, or disubstituted? So one of the things that happens is with 2 substituents, because you can only have one substituent at each position, it turns out there's only 3 ways to do it. One, 2, 1, 3, and 1, 4. If we go over to the next carbon and try to say that that's 1, 5, we would want to circle the other direction, and 1, 5 would just be the same as 1, 3. Now, that wouldn't be too bad, but it turns out in many cases we don't even use the numbers. What we use is that when our 2 aromatic substituents are 1, 2, we have ortho, often abbreviated as O. When they're 1, 3, that's called meta. And 1, 4 is known as para. All right, so how do we use this now? So here we have an aromatic ring that has a bromine and a chlorine. And we can see that the bromine and chlorine are in a 1-3 relationship, or what we call meta. So now what order do we name the substituents in? Same thing we've been doing. They always go alphabetical. So this becomes M or meta, bromo, chloro, benzene. So how would we name this one? Well, those 2 groups are in a 1-4 relationship. So that would be para. And we have an ethyl at the bottom and a methyl at the top. So para, ethyl, methyl, benzene. But didn't we just learn a few minutes ago that methylbenzene has another name? We did. We learned that methylbenzene is also known as toluene. So we can simplify the name and substitute toluene for methylbenzene. And so then, instead of para-ethyl-methylbenzene, we get para-ethyl toluene. All of the information is still there. The para tells us that we have 2 substituents. We know that one of them is an ethyl because the name is written out. And we know that the other one is a methyl because methyl is part of toluene. Now, these terms ortho, meta, and para, you can only use them when you have exactly 2 substituents. What happens when you have more than 2 substituents? Well, when you have more than 2 substituents, at that point you have to go back to the same method of numbering that you did for cycloalkanes. So this one, for example. In fact, we did a very, very similar to one like this where they were all methyl groups on a cyclohexane. So we already know that we're going to start numbering here and go clockwise. And so then from there, we just list our substituents in alphabetical order. 2-bromo, 1-chloro, 4-iodo-benzene. But the common names can also come into play here as well. So if you were going to name this one without common names, we would start the numbering down here at this bottom chlorine and go around this way. And that would give us 1,2-dichloro, 4-methyl-benzene. But again, we learned previously methylbenzene is toluene. So can we use that here as well? We can. But that also can change the numbering. So if we're going to use toluene as our root name, because we're using toluene as our root name, that changes our numbering. It automatically defines the carbon with the methyl group as carbon number 1. And so instead, we get 3,4-dichlorotoluene. So which name is right? Well, based on the IUPAC rules, both of them are right. Do we like one better than the other? Yeah, usually the shorter the name, the better off we are. But this is one of the things that can often get complicated, get more confusing with aromatic nomenclature, is sometimes there can be 2 or 3 or 4 or sometimes even more different names for the same compound. So now you should go and do the practice sheet on aromatic nomenclature and come back and go over those solutions.